Our journey begins at the source. High-quality raw milk from advanced sustainable dairy farms. Thermal stabilization is critical. Raw milk must remain at exactly 4 degrees Celsius until it reaches the plant. A fleet of specialized tankers maintains the cold chain during the high-speed transit to the processing facility. Millions of liters of fresh milk arrive daily at our central processing hub. Each bay is equipped for high-speed unloading, while maintaining total anaerobic conditions. Before the main transfer, the milk is inspected through inline sensors and visual sight glasses. Every batch undergoes rigorous testing for fat content, acidity and microbiological purity. Advanced analytics determine the yield potential for the churning phase. High-capacity centrifugal pumps move thousands of liters per minute into the central reservoir. Once inside, the milk is agitated constantly to prevent fat separation. Before the separation stage, from reception we move into the heart of the facility, where the milk begins its physical transformation. The first step is clarification, removing any microscopic impurities through intense centrifugal force. Operating at thousands of RPMs, these separators isolate sediment with surgical precision. Maintaining constant pressure ensures a steady flow rate into the separation tanks. The clean-in-place system ensures all pipelines are chemically sanitized between batches without disassembly. Rotating spray balls reach every millimeter of the tank's interior with high-pressure sanitizing agents. Conductivity sensors monitor the concentration of cleaning agents to ensure a residue-free environment. Rapid cooling following clarification stabilizes the raw milk's enzymatic activity. Inline optical sensors verify the density and purity of the stream at 60 frames per second. Any non-conforming material is instantly diverted for secondary filtration or byproduct usage. Standardization ensures a consistent fat percentage, vital for the engineering of high-yield butter. Automated, internal inspections verify that the sanitization process is absolute. The preparation is complete. The pure, standardized milk is now ready for its first major transformation. Now the separation begins. Using centrifugal force, we split the milk into its two primary components. At 10,000 rotations per minute, the heavier skim milk is forced to the outer walls, while the lighter cream remains at the center. The physical split is absolute. The skim milk is diverted, leaving us with the essential raw material for butter-heavy cream. Real-time viscosity monitoring ensures the cream has the exact density required for efficient churning. At 40% fat, the cream is now highly concentrated, a golden liquid that will soon become butter. After 12 hours of aging, the cream reaches the ideal acidity and fat crystal structure. Precision modulating valves balance the flow between the separators and the holding tanks, preventing back pressure. The surge tank acts as a buffer, ensuring a constant supply of cream for the next stage of processing. Constant monitoring of line pressure prevents the separation of fats. Within the transport pipes, the contrast is now clear. The cream, concentrated and rich, is isolated and ready for its next stage. Flash cooling to 5 degrees Celsius prevents unwanted fermentation as we move toward pasteurization. From the separators, thousands of liters of cream are channeled toward the pasteurization and aging phases. The separated cream is now routed into the thermal treatment stage, the heart of the pasteurization process. Pasteurization is critical. We heat the cream to eliminate bacteria and deactivate enzymes that can spoil the butter's flavor. The cream is held at 95 degrees Celsius for exactly 15 seconds. to ensure total biological stability. Safety diversion valves monitor every millisecond. If the temperature drops even half a degree, the flow is instantly rejected. After treatment, the cream is rapidly cooled back down, preparing it for the biological aging process. Natural starter cultures are added to develop the characteristic buttery aroma and texture. Slow speed agitation ensures an even distribution of the starter cultures without damaging the fat structure. Precision cooling jackets keep the cream at exactly 15 degrees Celsius, the perfect temperature for flavor development. The separated cream is now routed into the thermal treatment stage, the heart of the pasteurization process. A pH level of 4.65 indicates perfect lactic acid development for premium butter flavor. Under the microscope, we verify the physical transformation of fats into the precise, crystalline matrix required for churning. Validation complete. The ripened cream is released for the most mechanical stage of its journey. Thousands of liters per hour are measured with high precision to ensure total batch traceability. The primary processing is complete. We now enter the churning hall, where engineering turns cream into butter. The heart of the butter engineering process, the continuous churn. Ripened cream is injected into the primary cylinder, where high-speed beaters begin the mechanical confrontation. Rotating at thousands of RPMs, internal beaters violently shatter the fat globule membranes. This intense mechanical energy forces the liquid fat to escape and bind together into tiny grains. Phase inversion. The moment cream ceases to be a liquid and becomes butter, grains suspended in buttermilk. Engineers monitor rotation, speed and temperature to the millisecond to ensure perfect grain size. Predictive maintenance sensors track mechanical resonance to prevent even the slightest deviation in rotation. Millions of fat globules have now fused into solid grains. The engineering of the butter itself has begun. Massive torque is required to maintain rotation as the cream thickens into solid fat. Double-acting seals prevent any external contamination, while allowing the high-speed shaft to penetrate the sterile chamber. In the second stage, the newly formed grains are gently agglomerated, growing in size as they move toward the separation tray. This snowball effect is the physical manifestation of the fat globules, fusing into a solid mass. As the viscosity increases, the motor load is monitored to prevent shearing of the newly formed butter grains. The geometry of these beaters is engineered to provide maximum agitation while maintaining total sanitary compliance. The churn completes its cycle. A constant stream of butter grains and buttermilk now flows towards separation. Act 5 concludes the cream has been broken and the grains are formed. Separation is next. Now we separate the newly formed butter from the liquid buttermilk using high-frequency vibrating screens. Maintaining constant pressure prevents the premature separation of cream components before it reaches the churn. This byproduct buttermilk is diverted for use in other food processing industries, ensuring zero waste. And what remains is the pure milk fat. Thousands of tiny butter grains now ready for washing. This washing stage is critical for shelf life, ensuring the butter remain pure and stable. Only ultra-purified water is used to ensure no off-flavors or contaminants are introduced during washing. The grains are now washed and pure. They move forward to the malaxation phase, where they will be worked into a solid mass. A final dewatering screen uses precise vibrations to ensure the grains enter the working stage with the correct moisture profile. At this stage, the grains are pure, consisting of over 80% milk fat. The reclaimed buttermilk is channeled to a dedicated polishing station to recover any remaining fat particulates. Secondary centrifuges extract the final traces of butter fat, achieving 99% recovery efficiency. Flow control systems manage the volume of byproduct, heading to the evaporation and powdering sector. Infrared moisture probes scan the grains at 30 cycles per second, providing instant data to the malaxator's computer. Current moisture is measured at 14.2%, well within the parameters for high-grade butter production. Internal screw conveyors now feed the grains into the malaxator, where the physical structure of the butter is finalized. The separation of butter from buttermilk is complete. We now enter the malaxation phase, salting and working. Now the malaxation phase begins. This is where discrete butter grains are worked into a smooth, homogeneous mass for salted butter. A precise brine solution is injected. Automation ensures every gram of butter has the exact same sodium profile. High-precision pumps calibrate the additive flow based on real-time fat content measurements. In the first stage of working, the augers apply immense pressure to fuse the grains and distribute the brine. Heavy-duty sanitary seals manage the extreme pressures generated during the texturization process. The transition is complete. The discrete grains have fused into a single, continuous body of premium butter. Secondary working ensures that moisture is broken down into droplets, so small they cannot be seen, resulting in a perfectly dry appearance. A partial vacuum is applied to remove all occluded air. This increases the butter's density. Constant negative pressure is maintained to ensure the engineering of a zero bubble final product. The homogenization valve provides the final mechanical work, ensuring absolute uniformity of the water and oil emulsion. Mechanical work generates friction heat. We monitor the output temperature to ensure the fat crystal matrix remains stable. Every millisecond, the system adjusts the working speed and brine injection to hit the exact engineering target. The working is complete. The result is a continuous flow of finished butter, engineered for perfect spreadability. This density is the hallmark of modern industrial engineering, achieved through years of mechanical refinement. A final verification ensures every kilo meet the legal and culinary standards. Before heading to final texturization, Act 7 concludes the butter is worked and salted. Now it must be thermally finished to lock in its texture. The final stage is texturization, a controlled cooling process that determines the butter's final crystal structure and spreadability. By rapidly cooling the worked butter, we force the formation of a specific fat crystal network. The scraped surface heat exchanger is the ultimate texturizer, continuously removing cold butter from the walls to ensure uniform cooling. Internal scrapers rotate at high speed, maximizing heat transfer and creating a perfectly consistent crystal distribution. Maintaining the output at 11.2 degrees Celsius is the final secret to the perfect spread.